Hi everyone, myself Dr. P. Ashok Babu, working as Professor and Head EC Department. So in this video, I am going to discuss about the some important definitions of the transmission lines. First one, define capacitance in a transmission line. So a capacitance is defined as a loop capacitance per unit length of wire. So the units for farads per farad per kilometer. So define conductance in a transmission line. The conductance is G. The conductance is defined as the loop conductance per unit length of a wire. Its units are mho per kilometer. Then which is opposite to the resistance. Conductance is opposite to the resistance value. So what are the primary and secondary constants of a transmission line? So the primary constants of a transmission line are R, L, C, G. Resistance, inductance, capacitance, conductance are the primary constants of a transmission line. So these are distributed parameters. These are also known as the distributed parameters, and these are distributed throughout the transmission line. So the secondary constants are there are two secondary constants. One is a characteristic impedance, and other one is a propagation constant. Characteristic impedance is Z0, and the propagation constant is PR gamma. So they are the secondary constants of a transmission line. Define attenuation. Attenuation in electromagnetic system is due to a conductor and dielectric losses. Because of these two losses, we have attenuation in a transmission line or wave propagation. So define delay transmission line. So it is the transmission line of the appropriate length to result in a specific time delay. Next, what is a coaxial cable? A transmission line formed by two concentric conductors separated by a dielectric designed to confine the fields and their energy in the medium between said conductors is known as a coaxial cable. A coaxial cable is having two conductors, inner conductor and outer conductor. So between the two conductors we have a dielectric medium. So define propagation constant. So the transmission line which has attenuation constant alpha and phase constant beta is called the propagation constant. A combination of both attenuation and phase constant will give a propagation constant, which is P is equal to alpha plus J beta, where alpha is attenuation constant, beta is the phase constant. Next, define phase distortion. For an applied voltage, voice voltage wave, the received waveform may not be identical. Suppose when we are transmitting the signal shape may be like this. When we are receiving the signal shape is same, but there is some difference in amplitude. So like that, for an applied voice voltage wave, the received waveform may not be identical with the input waveform at the sending end. And since some frequency components will be delayed more than those of the other frequencies, this phenomenon is known as a delay or phase distortion. So this will occur when we transfer the information from one place to the other place or from source to destination. So what is the distortionless transmission line? So a distortionless line is one which the attenuation constant is frequently independent, while the phase constant is linearly dependent on the frequency, which is known as the distortionless transmission line. So define characteristic impedance. So here the characteristic impedance is the impedance looking into an infinite length of line. It is also the ratio of voltage applied to the current flowing will give the input impedance of an infinite line. So which is known as a characteristic impedance. So define transmission line. So what are the different types of transmission line? So a transmission line is a system of conductors that transfers electrical signals from one place to the other place, or from source to destination. So the different types of transmission lines are coaxial transmission line, parallel plate or planar transmission lines, strip lines, micro strip lines. These are some examples of other types of transmission lines. Define line parameters of a transmission line. So here the performance of transmission line depends upon the parameters of a transmission line. So the transmission line has mainly 4 parameters. So resistance, inductance, capacitance and conductance. So these parameters are uniformly distributed along a transmission line. Hence, it is also called the distributed parameters of a transmission line. Next, define resistance in a transmission line. So it is defined as the loop resistance per unit length of a wire. The units for resistance are ohm per kilometer. So here resistance and conductance both are opposite to each other. So define frequency distortion. So a complex or a voice voltage transmitted on a transmission line will not attenuate equally and the received waveform will not be identical with the input waveform at the transmitting end. So this variation is known as a frequency distortion, or when we transmit the information, the different frequencies, the different signals may receive at the receiver at different frequencies. So this is known as a frequency distortion. So what is the condition for distortionless line? So here the condition for distortionless line is RC is equal to LG. RC is equal to L into G. Or R by L equal to, we can write R by L is equal to G by C. G by C, which is a condition for distortionless line. So what are the load lines? So it increases the L by C ratio to achieve a distortionless condition in a transmission line. So this can be done by increasing the inductance of a transmission line. Increasing the inductance by inserting a inductance in series with the transmission line is termed as loading, and such lines are known as loaded lines. So here define the phase velocity. The phase velocity of a wave is the rate at which the phase of the wave propagates in space. So this is the velocity at which the phase of any one frequency components of the wave travels, which is known as a phase velocity. Describe infinite transmission line. If a line of infinite length is considered, then all the power fed into the line will be absorbed. The reason is as we move away from the input terminals towards load, the current and voltages will decrease along a line and becomes zero at the infinite distance. These lines are known as a infinite transmission lines. So what is a lumped loading? In lumped loading, loading is introduced at uniform intervals. So it may be noted that hysteresis and eddy current losses are introduced by loading, and hence design should be optimal. Then only we can have the better performance. So while line parameters are called distributed parameters. So due to transit time effect, the whole line inductance or capacitance cannot be assumed to be located at a particular point in a free space. So here the inductance and capacitances are distributed throughout the transmission line. Then these are therefore called as the distributed parameters of a line, transmission line. So define inductance of a transmission line. It is defined as the loop inductance per unit length of a wire. The units for the inductance are Henry per kilometer. Define conductance in a transmission line. Conductance G is defined as the loop conductance per unit length of a wire. Loop conductance per unit length of a wire is defined as a conductance. So its units are mho per kilometer. It is opposite to the resistance. So what are the primary and secondary constants of a transmission line? The primary and secondary constants of a line, transmission line are, the primary constants are resistance, inductance, capacitance and conductance are the primary constants of a transmission line. The secondary constants of a transmission line are, so characteristic impedance and propagation constant. Both are the characteristic impedance Z0 and propagation constant P are the secondary constants of a transmission line. Define wavefront. So for an electromagnetic wave, the wavefront is represented as a surface of identical phases. If we have identical phases, then we can call it as a wavefront. So what is a coaxial cable? A transmission line is formed by two concentric conductors separated by a dielectric medium designed to confine the fields and their energy in the medium between the said conductors. So it is having the two conductors like this. So outer conductor, inner conductor, and both are having the different radius. In between these two, inner conductor and outer conductor, the medium is filled with a dielectric material, so which is known as a coaxial cable. What is the dispersion of a transmission line? So dispersion means the propagation velocity and the line is not constant with frequency, which is known as a dispersion. So what is a lossless transmission line? A transmission line is said to be lossless if the conductors of the line are perfect and the dielectric medium separating them is lossless. Then we can call it the transmission line as a lossless transmission line. Define group velocity. The group velocity of a wave is the velocity with which the overall shape of the wave's amplitude, known as the modulation or envelope of the wave, propagates through the space. Define characteristic impedance. The characteristic impedance is the impedance looking into an infinite length of a line. It is also the ratio of the voltage applied to the current flowing will give input impedance of an infinite line. Define E-plane. E-plane is an electric plane. So it is defined as the plane containing the electric field vector and the direction of maximum radiation. That is known as a E-plane. Similarly, define H-plane. So it is defined as the plane containing the magnetic field vector and the direction of maximum radiation. So define 1 radian. So it is defined as a plane angle with its vertex at the center of a circle of radius r that is subtended by an arc whose length is r, which is known as a 1 radian. Define 1 steradian. It is defined as the solid angle with its vertex at the center of a sphere of radius r that is subtended by a spherical surface are equal to that of a square with each side of the angle with each side of the length r. Mainly the steradian is nothing but it is a solid angle. It is used to measure the solid angle in a wave transmission. Define polarization of a radiated wave. It is defined as the property of an electromagnetic wave describing the time varying direction and the relative magnitude of electric field vector. So define conduction dielectric efficiency. So it is the ratio. It is defined as the ratio of power delivered to the radiation resistance RR to the power delivered to RR and RL. So it is the ratio of RR to RR and RL. It is known as a conduction dielectric efficiency. Define refractive index. Refractive index of ionosphere is defined as the ratio of phase velocity of a wave in a vacuum to the velocity. Define directivity. So it is a measure of how focused an antenna coverage pattern is in a given direction is known as a directivity. Define dynamic range. So it is a range of power between the maximum signal and the minimum signal that can be measured. So define far field. The far field corresponds to an RF source to measurement antenna. RF source to measurement antenna distance great enough that energy radiates from the source only in a radial direction, which is known as a far field. So define front to back ratio. So it is a ratio of the gain. It is a ratio of the gain in the maximum direction to the opposite direction. It is known as a front to back ratio. So there are some definitions in transmission line 1. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.